Good morning. This is the FT production department in Castel del Piano, Tuscany, Italy. Now we are introducing a new kind of machine, a new complete machine that is the vacuum pressurization with leak detection procedure and the charging machine. The machine is this one, the iROCKALL HS number 2 with two working lines. This machine was made by FT department for a special Italian customer, to which it was configured a special working procedure in order to satisfy their requirements. The machine is very simple to describe. It is composed by an upper cabinet with a very simple interface with emergency switch, principal switch, and the heart, the brain of the machine is this. It is the electronic control with the digital touch screen in order to make all the operation of the machine by touch, just like a touch screen. There is a horn, siren. There are a couple of lights with some working lights in order to evidence the status of working of the machine. On the side there is the internet connection in order to have remote control of the machine. The downside part of the machine is an hydraulic and pneumatic control. So, just opening the cabinet, I can show you the components, the main components of this machine. Okay. Okay, we have the vacuum part, the vacuum section, that is this one, with vacuum sensor, relevant open-close valve to section the vacuum process, and the relevant filter. Then we have the refrigerant section that is connected to this electric valves with the internal refrigerant metering system that is shared in this case between the two refrigerant lines in order to have a serial charging process. Then we have the pressurization side of this machine with the electric valve, this side and this side. We have two small pneumatic vacuum pumps in order to make an efficiency on the discharge line. And then we have the electric pneumatic valve to command the small devices inside the head injector that now we will see later. On the back side of the machine, we have the inlet and outlet interfaces. We have the tracing gas inlet with maximum pressure of 40 bars. We have the refrigerant inlet, kind of all refrigerant except the explosive refrigerant, just like isobutane and propane. We have the vacuum pump that in this case, for the special customer requirements, we installed the Edwards E2M28. After that, we have the outlet of the tracing gas that typically the customer has put on the outside of the facility. And this pipe is the inlet of compressed air for the compressed valve inside the machine. The configuration of the machine for this special customer was realized with two couples of pipes with 8-meter lengths, but in this case we can configure the length of the pipes according to the customer requirements. So we have all these injector, and we will see the terminated pipes of one couple, into which we have the vacuum and pressurization injector and charge injector with the Hansen 1/4 releasing. and also vacuum and pressurization injector that make at the same time the vacuum for the device under test. Okay, after that we will see a typical working cycle of the machine in order to understand better how to set the machine and how the machine works in a element of the circuit of the customer. Thank you very much. Okay, now in this phase we will show you the main software functioning of this machine in order to show you the most important features of the software that is realized by FT engineering inside this electronic control. As already told, the control is a touch screen, so all the functionalities can be enabled with only the pressing of the digital pressing of some part of the screen. There is not keyboards, but this can appear if some password or some settings are required. So by pressing the menu button, there is the all window of the menu, to which there are some sub-functions available on the machine: cycle, system, machine, statistics, about, and shutdown. Let's see cycles. Cycles enable other sub-menu in order to set some all the feature about the cycle, so editing, new cycle, and showing cycle. Then we have system, that is all the sub-menu, and inside there are other functionalities that can be enabled to modify the function of the machine. After we have a machine menu, to which we have some important maintenance system in order to control the machine in case there are some issues. For example, we access to service menu, and here we have the I/O test, that is the test of input, digital input and output of the machine. So let's say, let's set the password, and here there is the window to which we have the list of the valve actually on or off in this phase, in standby mode, and the status of all sensors of the machine. Just pressing one button of this, there is the enable of the relevant electric valve that is inside the hydraulic cabinet that we have seen before. Other menu part is the statistics, to which there is an important function of the working result of each working cycle that has been realized during the job. For example, the last one was the cycle number 21 of May 3, 2016 at 4:29 p.m. In this part, there are all the results of the cycle that were reached according to the feature of the circuit. In this case, there is only 5-liter circuit connected to the line number 1 of the machine, and all the parameters that were set and reaching during the cycle, the working cycle. Okay, another menu function is very simple, the feature of the machine in order to claim this number, in order to give to us the information about the machine, and to search in our database about the main features of the machine. The last menu is a shutdown function, to which we can shut down the machine in order to shut down digitally the machine. After that, we can press the switch off device in order to shut down definitely the electric valve and the pump. Now it is time to make a new working cycle, just like an example, in order to show you the different working phases of this machine. The device to test is composed by a 5-liter tanks with the two injectors at the same time connected. This is a requirement of the special customer, and we will charge a pre-compiled cycle in order to make an example on this circuit. This is only an example. So we go on cycle. We actually have already pre-charged the cycle. We only want to edit. So again, according to the parameters that we saw before, we select the charge cycle number 21, and in this case we have again a vacuum cycle as a first phase. Second phase, it is a pressurization with decay test with maximum 50 kilopascal observed in 60 seconds. As you can see, the values can be modified by pressing your finger inside the proper window to correct. And the pressurization value is set, we can set it to 10 bars. So we set 1000 kilopascal. Okay. After that, we have if the decay test is okay, so 50 kilopascal are not reached during the decay test, we have we set the machine set the device to 400 kilopascal and waits the time to test the leakage with the manual leak detectors that we have here as an example. After that, we set residual pressure to 0 kilopascal, just to save the machine to make a second phase of vacuum. So what happened? The machine firstly discharge the circuit, after that discharge the internal line on the injector, these ones. After that, realize a second vacuum in order to prepare the circuit to accept the refrigerant, and after the vacuum is realized, charge 100 grams. As you can see here, we can set each value. We can modify the value according to the requirements of the circuit. For this example, we set 100 grams. It is important to remark that it is not mandatory that the machine make a final refrigerant charge after the full test. In fact, it is possible to leave the circuit in some other condition. For example, after the manual leakage test, it is possible to leave the circuit to a certain pressure of tracer gas in order to make other tests later, or because the customer want to sell the product with some pre-charged tracer gas on the circuit. Or it is possible to leave only the circuit with vacuum for other phases that will be performed by other production lines of refrigerant charging. So the machine is very flexible to be programmed in this sense. Okay, now we save. Okay, we ask. Now we select the cycle. As you can see here, the parameters are reading in real time: temperature, pressure of the refrigerant, vacuum, and we select the cycle. The cycle is the cycle number 21. We select with the finger. The cycle is ready. Here again the most important parameters, that if you want to have a more detailed information, you press info, and you have the all resume of the cycle. So you have vacuum with low time, sorry, with low modality. The target is to reach 70 Pascal within 400 seconds. Rising time of 60 seconds with the threshold limit upper of 800 Pascal. After that we have the observation time of a pressurization up to 10 bar with maximum decay test of 50 Pascal. After that we have the time to make a manual leakage test at working pressure of 400 Pascal. Kilopascal, so 4 bar. After that we have vacuum, and after that we have charge of 100 grams. So let's start the cycle. Very simple to start the cycle. We press start. Okay. Now the machine is realizing the vacuum of injector that allow to eliminate the residual refrigerant traces gas inside the injector. Now it is starting the evacuation phase. So this is the actual vacuum level, and we have more than 400 seconds in order to reach the low threshold of 75 Pascal. We try to wait this time, and after that we'll start the rising test for 60 seconds according to our vacuum parameters. Okay, now it is the decay test, the rising test. We had to wait for some seconds, about 10 or 15 seconds according to the circuit test, in order to reach the regime of the vacuum level, and after that actually starts the rising test. As you can see, we have 30 seconds left, and the vacuum is more or less stable. This means that the circuit basically has not leakage inside. Okay, the first vacuum test is quite finished. 1 second, test okay. Now it is time to pressurize the line. The machine is now pressurizing the line. This is the actual pressure of the read on side sensor. So the machine is now making some policies, internal policies to obtain the right pressure. It is important to know that as the circuit is very small and the machine is programmed to work on very big circuits, this pressure should be 10 bars, but the high level of pressure does not allow to be more exact for physical reasons. So at this moment we are making a pressure at around 10 bar. Now there is the tightness test, and the machine is computing the total delta P during the 60 seconds that we have set on the cycle program. Okay, the decay test is okay. Now the machine is discharging the circuit. This is the actual pressure inside, and now the machine has realized that the delta P is only 7 kilopascal, so it is very good result. The machine with an alarm with these windows, with this button, it is possible to check that the circuit was actually accepted. And now it is time to wait for the manual leakage test with the manual detector. The machine says that it is possible to make this operation because the red, the orange and the blue lights are blinking. So we simulate a leakage test. We make here the circuit. Okay, this is only a simulation, so
just only to check that this is the phase operation that is waiting for the before going ahead with the cycle. Okay, we say that the circuit basically has not leakage, so at moment to continue the cycle we press the start button. 3, 2, 1, go. Okay, now the machine is discharging the circuit again and discharging the lines in order to prepare to the last phase. I mean, it is the vacuum and after that charge. Again, we remark that the other phase could be only vacuum or could be only repressurizing the circuit or reaching a lower pressure level of tracer gas on the circuit. So we wait for the discharge of the line. Test is finished. Now again the vacuum test, just to prepare the machine, the circuit to charge. We remark that the minimum discharge time from after pressurization is 3 minutes according to the circuit features, and these values can be set inside the machine. Minimum time is 3 minutes. Okay, it seems that the vacuum test is okay. Now the machine make the charge. 100 grams. Start. Stop. Okay. Cycle has finished and the machine said everything was okay. Just to be sure that if I want to check the report of this last cycle, I have on the working result of the system, and here there is the resume of all the values that were reached during the vacuum, pressurization and charge process. So the work was correctly, there were not any alarms, so the cycle is okay, and the product, the circuit can go ahead on the production. When I finish to work, the machine is ready to make another cycle, so if I press start again, I can start again a new cycle. When I finish to work, if I want to shut down the machine, I go here, press shut down, say yes, and the machine shuts down. Thank you for your attention, and goodbye.